да го структурира това. Но по принцип, отговорът е да, по същество точно за такива неща, за изясняване на балансови числа се използват такива разни supervised learning, при който всъщност идеята е, че ти не му даваш цел. В смисъл, supervised learning може да казваш преисторията на това, което изследваш, примерно на данък. В случай няма да има смисъл, но примерно даваш преисторията на факторите и едното с другото, той казва, ето това, ето такива стойности и това отговаряло и той се научава. Това е supervised. Не му даваш предистория, всъщност не му даваш кой от тези са ценни, кои са целева и кои са фактори. Но кажеш тези ми копирай, така че и това дето е така, че го дефинира какво искаш и те тогава се намират някакви стойности, между стойности, разделяне на кластери, сегментации и така, което е също.
Hello everybody, can you guys hear me?
Чакай да пусна това.
Yeah, this is good.
Да, аз съм се
Okay, so I'm going to talk about intelligent question answering using the wisdom of the crowd. So first about me, I have done quite a lot of work on natural language processing. I worked in Berkeley in biomedical text processing, then I work on machine translation, the languages like Malay, Indonesian and Mandarin in the National University of Singapore. Currently I'm in the Qatar Computing Research Institute, where I work on problems related to question answering, machine translation, more recently fact-checking, and of course here the main focus is Arabic and its dialects, and I have worked on lexical semantics, relation extraction, sentiment analysis, and so on and so forth, also chatbots. Okay, so let's start with the basic question. I mean, who really needs research in question answering if you have Google, right? So if you ask Google something like, even in Bulgarian, кога е роден Бойко Борисов, it tells you, right? So it knows that. Okay, and if you ask it, okay, how old is Donald Trump? It tells you 71 years. That's good, right? So now what if I ask the question in a little bit different way? I mean, can somebody tell me how old Donald Trump is, right? You get something like that, right? And I mean, it's really the same question, just asked a little bit differently, right? And it completely fails, right? Or, you know, okay, you ask it something like, okay, when was AUBG founded? It gets it right. And then you say, where is Telelink based, right? Not that difficult kind of question. I mean, I cannot really figure it out from this list. Or you have like, what areas of data science does Scient offer services in? It doesn't even really kind of, you know, find Scient. You see that Scient is kind of, you know, kind of removed from the search. And you know, if I ask something like complicated, like, sorry, that's Bulgarian, кога е следващият семинар или конференция на софтуерни разработчици, обичам събития с готини лектори на интересни теми, ако кои има и бира и пица, още по-добре. Okay, and then, you know, this is what you get back. So, it doesn't quite work, right? So, I mean, and I can have a practical question. So, for example, can I get a Qatari residence permit for my wife while she's currently in the country on a tourist visa, right? I mean, and good work with that. By the way, an answer to this question actually exists, but you have to do a lot of, you know, different kind of, you know, tweaking with keywords and you know, scanning and this and that. So, and so the kind of research that we are targeting is you want to be able to answer complex questions, not when is somebody born, but something like that, right? I mean, like, can I get Qatar residence permit? And then the idea is like also to have interactivity. So, for example, you find the answer, let's say in Qatar Living, it's a web forum, just like Beg and Mama, just like, you know, like Stack Exchange and so on and so forth. And then we want to have, to be able to have follow-up questions that we ask, and then the system to be able also kind of to give an answer to this follow-up question, you know, in the context of what was asked before and what was also answered before. Okay, can Google do that? We have seen probably not. And neither can Siri. And probably I should add not yet. Okay, so I mean, there's a lot of research in that direction. There's a lot of investment from the giants, right, in question answering. I mean, everybody wants to get in this direction. And this is what we have been focusing on, right? So this is the question answering team in the Qatar Computing Research Institute. So a bunch of people here. This is a collaboration project with MIT, right? We have like a big 7-year collaboration with MIT, and you know, those are some of our collaborators there. And initially we started with an application called the Doha City Browser, which is, the idea is like to have a smartphone application that can give information about Qatar, Doha, and the region. And the motivation was that in 2022, the World Cup in soccer, in football, is going to be in Qatar, right? So kind of, if you want to hear some kind of tourist information guide, you know, that tells you places and things like that. And the idea was to be speech enabled, we have both English and Arabic. Okay, so basically, okay, I don't have time now to show you the demo, but you say something like, okay, I want cheap Italian restaurants in Doha with takeout, and basically it needs to do a semantic parsing, like to understand that, see here, that cheap is about price, Italian is about cuisine, Doha is about location, and takeout is amenity, right? This is called, kind of in the speech community, in the dialogue community, this is called semantic parsing. I mean, I call it concept segmentation and labeling. It's kind of a related problem. And then, you know, it kind of shows you results on a map, right? This is kind of what's the application, the starting thing. So basically here the main problem is how do you do that, right? So you start with text like that. You need to do this kind of parsing. Then you probably do a little bit of normalization because maybe in your database the price is not cheap but is low. This is the standard value. So maybe you have a little bit of standardization. And then you convert this in some kind of query, maybe MongoDB, and then you get back the results and you show them on the map. And kind of, you know, in this kind of application, you see that the main difficulty, the main research part is how you do the semantic parsing, right? How do you understand what the text really is about? So, and I want to tell you a little bit about how you do that, right? How do you do this kind of semantic parsing? So we start with something called semi-Markov conditional random fields. It's like, you know, fancy machine learning method that basically kind of takes the text and first splits it. Says, okay, is there A is one segment, Lebanese is a second segment, Cafe is another segment, Doha West Bay is another segment, and then after the segmentation performs labeling. It says, okay, this segment is cuisine, this one is location, the others are not interesting, right? And the thing is that this model can fail sometimes, so what we do is we use a more expensive, more linguistically motivated model to kind of rerun the n best decisions returned by this model, right, to refine the results, potentially get a better thing. And for this we do kind of syntactic kernels, kind of use those kind of, you know, we represent the language with some kind of tree structure, and then we kind of compare this tree structure to training examples, right, with something called kernels. I mean, those that know machine learning probably have seen that. But basically it's some kind of, the idea is like what is there in the tree, right? The tree can be more or less similar to what we had before. Along my route is one interesting unit. It's like location, steakhouse is like cuisine, the rest are not interesting. We can also kind of have something like a little bit more complicated, where to each node we add its part of speech. For example, next is an adjective, steak is a noun, house is a noun, and matching those kinds of trees might give you a little bit better results. You can have full syntactic tree, which has even more structure, right? It's kind of trying to understand the language. You can have shallow syntactic structure, where you say, okay, this is a verb, this is the group of the noun phrase, like my route, the whole thing functions as a noun, or let's say, the next tech house is another thing that functions as a noun, this is the noun phrase, this kind of a little bit less deep syntax. You can have discourse tree that tells you that, okay, this phrase, along my route, tell me the next tech house that is within a mile. This is kind of has two parts, and the first part is the nucleus, the main part, and this is kind of the satellite, and then there's an elaboration relation between those, and kind of if you start modeling those kind of, you know, relationships, you can get better results. And you can do other things. You can do some kind of clustering, and you know, you can have clusters as sister nodes to the you know, those are cluster IDs next to the, you know, to the particular node. Sorry, I'm rushing because we're kind of a bit behind schedule, and please let me know. Is it too fast?
It's okay.
It's okay, right? And you know, you can do other things. You can kind of have, you know, when you're matching the trees, you can do kind of some approximate string matching, you know, let's say using latent semantic analysis, kind of, you know, combining different things. So now the question is, I mean, what is a good application of that? And it turns out that this kind of semantic parsing is exactly what chatbots do. And chatbots are important. Why? Well, just to cite some kind of, you know, famous quotes by the CEO of Microsoft. He's saying that chatbots are conversation as a platform, that this is the third runtime, that they are as important to humanity as the operating system or the web browser. Okay? So there's a lot of hype, obviously. There are plenty of tools, there are probably more, right? Everybody's there. All the big companies are represented. IBM, Microsoft, you know, and so on and so forth. And basically, what does it do, right? What do all these tools do fundamentally? I mean, you start with something like, I'm looking for a Mexican restaurant in the center of town. You run it through one of those tools, and it does two things. The first thing is finds the entities in their types, which is the same task that I have presented to you. The second thing is it also has an intent, a global thing. Okay, what does the user want to achieve? So kind of what I have presented to you as the first word was just like targeting the entities. And then you kind of retrieve something from a database and you generate some output. I'll come back to chatbots because I think it's a nice topic, with a little bit different approach shortly. Now the question is, okay, so far the result was coming from a database, right? It's good when you have the database, then all that you need to do is understand the question, convert this into a query, and then you have the result from the database. The question is, where is the data coming from, okay? How does it end up in the database in the first place? And this is the main focus of, kind of this talk. So the idea is to go and to get it automatically from web forums, okay? This is called community question answering. So the classic question answering was, okay, I type a question, then maybe I analyze it a little bit. If it's like a simple factoid question where the answer is a name of a person or of a location or some kind of money amount or something like that, I try to understand that, and then I try maybe kind of do some query against Google, maybe I get the most relevant pages, maybe I chop it into paragraphs, then I kind of select the most promising ones, and then kind of do some more expensive, natural language processing to understand and to find the answer, right? Then I compare the answer type to what is expected and then return it to the users. That's the classical thing, right? So community question answering is different. So community question answering is basically mining forums. There are many pairs of questions and answers. It's kind of easier, right? But the kinds of questions that you can answer in this way is more complex because people can ask much more complex questions, not just who is the president of the US or when somebody is born, but something much more complicated as we have seen, right? So the idea is like to use that to be able to answer those kinds of questions. Of course, it's not so simple. So I'm looking here at Qatar Living. It's a web forum in Qatar. It has about 2 million answers, 200,000 questions. That's probably 4 times more than Begamama, right? But it's kind of still sizable. And then look at the questions, right? You have something like, it's not really just one question, it's multiple things. That's part of the, of the difficulty of the task. We have like, does immigration have any particular time for extending family visit visa? That's one question. And then in Doha Immigration Office only in Madinat Khalifa, that's kind of a second question, not even super well formed. And then we have like some need, which is kind of not even exactly a question, but those are 3 different kinds of things set. And then we have one answer, which is a good answer to one of the sub-questions. There's another answer that is kind of telling you, that is kind of about the duration of the answer, targeting one of the sub-questions. There are also some bad answers, right? This is kind of talking to other people or whatever. This is not a good answer. And then we have like potentially useful information that tells you, okay, it doesn't tell by how much I can extend the visa or where the location is, but it says, if you go in this Madinat Khalifa thing, just go to gate number 4, go directly to the reception without taking a number. It's kind of useful information if I'm actually doing it, but it doesn't answer my question directly. So you can think of these as 3 kinds of answers. So there are good answers to the questions that directly answer one of the sub-questions. There are bad that are just not relevant, and this is potentially useful, right? So the idea here is that the first task here is like to try to understand which are the good answers in the forum, because sometimes the forum can be very long. You can have like a few hundred answers there. What are the best ones? Okay, and this is something that we have done, and we have integrated into Qatar Living. I'm going to show you, in a bit. So the next thing is I can have a new question. Okay, I can come with a new question, and now instead of posting this question, right, into the forum and potentially creating a duplicate which the forum doesn't like, right, or this kind of from the forum perspective, if something similar has been asked, it's probably not a good idea to post it. From the user perspective, if I post something, I need to wait maybe for days for somebody to come to answer me. That's also not good. If there is already an answer to some similar question, I probably want to know the answer now, right? And those can be complicated questions. So for example, there's this question which is somehow similar to the previous one, and when I come with this question, I can go into the forum, and probably some of those this question might be a perfect match to something else, or might be somehow relevant to can be somehow related to some other question, where in the list of answers to this other question, there might be also answers to my new question. And this is a new question that was not asked before. So you can think of this as kind of a triangle. So, the first thing is, okay, here's the forum, and there's a question, and there's a list of comments. I need to know which of those comments are good and which of those are bad. Then if I come with a new question, I want to find out similar questions, related questions to that one. And then, so basically, okay, how do I answer this new question? First, I need to go and find similar questions, okay, potentially similar. Then I need to find good answers to those similar questions in the long thread. Then I want to make sure that there are good answers to my question as well. Why do I need the third thing? Well, because, it can be a good answer because it kind of answers some aspect of the second question, but the second question can have multiple sub-questions, and what I exactly asked in this new question might be a little bit different. So you really need to solve all three sides of the triangle, okay? And I'm going to talk about how to do that. So, the challenge is, and the power of community question answering is that I can answer very complex questions, okay? By using what users have done before. This is something that Google cannot do, right? The problem, of course, is like this informal language, not much focus, and grammaticality, and this and that. There can be also language switch in a multilingual society like in Qatar. And the information can be spread over multiple threads, or multiple answers, and so on and so forth. And of course, it's a complex task at the end. It's not just like keyword matching. It's not just synonymy and so on and so forth. You need to model very complex relations, right? So, one way to do it is we have this kind of scary neural network, right? Where basically we model this as a ranking task. So, given a question, right, and two answers to this question, which of the two is better? You can think of this as the task. Let's say I have a question, I have 200 answers to this question. I want to re-rank them so that the best ones are on top, right? This is kind of what you might want to do. And in this case, I have some representation of the question, okay? I have some representation of the comments, and then I'm projecting this into some kind of hidden layer, and then I'm modeling the pairwise interactions between the question and the comment, between the question and the second comment, between the two comments. Then I have some pairwise features that are directly comparing them, and then I'm making the final prediction. So how exactly I'm representing the question and the comments? Okay, so there's a lot of feature engineering if you are talking about those features. So first of all, there are question-specific features, okay? So for example, even without looking at the answer, if I look at one particular question, I can predict whether this answer, doesn't matter what is the answer, whether this is going to be a good answer or not. Why? Well, because some questions are just stupid. There is no good answer to this question. It's a nice day today, isn't it? What is a good answer to this, right? The same for answers. There's this answer, so sweet, wow. This is not a good answer to any question, right? So you want to model that as well. And of course, you want to find model the relationship between the question and the answer. And there's also, the forum, the interesting thing is that the forum has also a lot of metadata. It is very important. Who is the person asking? Does this person generally ask questions that get good answers, or mostly stupid? What is the category where this is put? Because if it's the socializing category, people do all kinds of stuff, right? Or who is the person answering? Then is this the first answer in the list? Because if you have 200 answers, answer number 200 is probably people fighting with each other. They totally forgot, where the original question was and things like that, right? So you want to model those kind of things. And actually, I'm going to devote a lot of attention on modeling the conversation. Okay, so what do? We use basically, we take the original text and we use embeddings. Do you guys know what is embeddings? No? Yes? Okay, some people know. So, okay, I have here a slide. So basically, you have a word, and to each word, you associate, let's say, a 300-dimensional vector in the multi-dimensional space. Here you have two-dimensional projection, and you probably don't see much, but let's say baking, boiling, cooking are kind of close to each other in this space, or let's say here you have coffee and tea next to each other. So basically the idea is that you have like multidimensional space where points words that are semantically similar are close to each other, those that are semantically different are far away from each other, right? Now if I have a text, I can just have those kinds of vectors of the different words. I can probably just sum them up and come up with one vector that represents the entire question, another vector that represents the comment, and then I can maybe just calculate a cosine or some kind of similarity between the two, or, right, I can directly use them as input, those multidimensional vectors to the neural network. Okay, this is kind of in a nutshell what is going on. And you know, those kind of vectors, they are kind of pre-trained Google vectors. They are vectors domain specific that we have trained on the forum. They are kind of other kind of vectors that model syntax. There are different kinds of similarities that are coming from machine translation evaluation, right, and so on and so forth. And you know that there are kind of other kinds of features like that are saying, okay, does this answer contain a URL or an email, and you know how long is it? Does it have question words? Metadata feature, who is answering, who is asking, kind of some kind of user profile, and so on and so forth. Now the interesting thing that I want to talk about is about the interaction between the users. Okay, so I mean. The kind of the threat level features that are modeling the conversation. So one thing is position of the comment, right? Where is this the first comment, the second comment, or the 100th comment, because it matters. Another interesting thing is, suppose that comment number 7 says, thank you, and the person who posted it is the author of the question. What does it tells us? It tells us that somewhere among the answers 1 to 6, there is probably a good answer, okay? And this is a feature we kind of can give some kind of informally a bonus to those that, you know, are at position 1 to 6, right? Those are the kinds of things that you want to, I mean, you can do this, we can do a lot of this at the feature level, right? Which is good. But now there is another kind of problem that we notice. So here you have this question. I have a female friend who is looking for a teaching job in Qatar in January. What would be a useful portable gift to give her to take with her? And then we have those two answers, so we have different answers. And the first one is again, a couple of good best-selling novels. It's hard to find much here in Doha in the way of books. And then answer number 9 is a couple of good novels, all-time favorite movies. And now our classifier, the fancy one with the neural network with all the features and this and that, says that the first answer is a good answer to the question, but says the second one is bad. And human annotators tell us what are good. And if you think about them, they're kind of same thing, more or less. I mean, they you know, something with novels. So, you know, this kind of means that probably you want to have an additional constraint to the system, right? Because so far the system was looking kind of at the comments in isolation or maybe just in pairs, but not really kind of analyzing the entire thread, right? So probably want some extra constraint to say that if the answers are similar, you want to get similar labels, okay? And those relationships can be at any distance, not necessarily kind of neighboring. So one way to do it is you can have a classification for the label of each answer, right, independently, and then you can have a second classifier, right, that basically tells you whether those two comments should get the same label or not. So for each pair of comments, you have a classifier that tells you whether they should get the same label or not. And then you have some kind of, you know, global inference, then based on the, you know, certainty of the classifier, whether this should be a good answer or a bad answer, and based on the certainty of the second classifier that tells you whether those two nodes should get the same label or not, somehow you try to come with a global optimal solution. And you can do this with integer linear programming or GraphCut, which are kind of equivalent in some sense. And so he's like, you know, some example with the GraphCut. Suppose that you have this comment here, right? It's 80%, the kind of the node classifier tells you that it's 80% certain it should be good, 20% certain it should be bad, okay? And then this node here, the classifier really doesn't know. It tells you 50% good, 50% bad, okay? It cannot decide. But then you have the node classifier, the pair classifier that tells you, look, this node and this node, those two comments, should have the same level with 85% probability. Okay? And this one should have the same level with 15% probability. And then this one is 90% certain to be bad. So what level do you think this node should get? It should be good, no? Because it's like, so, and basically this problem can be solved with, you know, minimum graph cut, kind of you find the best, kind of the minimum cost, right? And there are algorithms for that. And of course you can do this kind of, instead of having two separate classifiers, you can do it kind of in a joint model where you don't need to kind of have two separate classifiers and you know, at the end have this graph cut, you can have the whole thing as part of one model. I'm not going to waste time on that. I'm just going to, this is something that we have integrated in Catalink. So if you go there, right, so first of all, it says here, okay, we show those kinds of ratings, see, rating 4 out of 5. It says that to this question, this is a good answer. And if you go there, you're going to, you know, you can go and see it. This works with 80-something% accuracy, but if you don't ask the classifier to give you always a solution, if you kind of eliminate the boundary cases, right, then it's like more than 90-something% correct. Actually, if you go on the website of Catalink and you try to find a bad prediction, we don't show what is bad answer, we only show what is good. If you try to find a bad answer that we have labeled as good, is very hard. They exist, but it's very hard, because basically it's like playing with the threshold of the classifier, right? It was kind of the people running the website decided, okay, we are going to push it a little bit higher, so that, you know, what we show was good, we are very, very confident it's really good, okay? And, you know, here it says that this is something developed by QCRI and MIT. Okay, so, and we can apply this to Bega Mama. We did not integrate it there, but basically kind of, we have training data. We have, so let's say 60,000, you know, answers, like probably like 8,000 or 9,000 questions manually annotated on English, and we have used kind of cross-language embeddings, cross-language techniques, kind of to apply this to Bega Mama, right? Yeah, we had some paper with a student last year. So now let's look at the other question, right? You come with a new question, like, can I drive with an Australian driver's license in Doha, in Qatar? And so he's like, you probably want to find this kind of related question, then you want to find this kind of good answer to this related question, then make sure it is also a good answer to the original question, right? Of course, you can have this kind of complex neural network where, you know, given two potential answers for two potentially related questions, you know, for this original question, you want to see which of those is better, something like that. I mean, yeah, and this kind of complicated, but it can be done. Another thing that can be done is you can actually have, you know, a neural network that tells you predicts whether this comment is a good comment to this second question. Another part of the network that predicts whether the two questions are asking the same thing or related thing. Another part of the network that tries to predict whether this comment is a good answer to this new question. And of course, there are some relationships between them that you can kind of, you know, start modeling with your own network. And it's something, you know, quite complicated. And there are more, I mean, this neural network kind of models the relationship between a new question that you ask, the related question, and the comment. This triple. But you remember that there were dependencies at the thread level. Kind of, we have modeled before the relationships between the different comments. We have said if those comments are similar, they probably should have a similar label. And now you can start reasoning the same way also about questions, so it gets complicated. And, you know, you can start by having those complicated structures, you know, that you are kind of trying to model those kind of relationships. And I'm going to skip that because it gets complicated. Okay, what we have here is we have this, okay, if I have some time, I can show you, actually, let me try, if there is internet. Okay, so this is the Catalink beta search, right? This is something that we have also integrated in their website, right? And here I come with a new question, for example, where I can buy tires, and here is direct answer from the forum that is automatically found. On Salva Road, you will find Pirelli, Kimo, and so on Salva Road. Before I was this petrol station, things like that. So this is automatically, right? I type in here a question, and I directly find an answer to this question without even having to post it. From the structural correspondence, and then we also have some way to measure similarity between words, because we have some probabilistic dictionary that tells us how similar they are. Okay, this is bad, this is broken. Anyway, so here this is kind of, again, asking a question in English and kind of answering. Okay, so suppose that I want to ask for the Qatar Living Forum, which is in English, I want to be able to ask it in Bulgarian or in Arabic. Okay, so now the thing is you can do this cross-linguistically, because those kind of word embeddings that I have shown you, right, they can be also cross-language, which means that the English and Arabic dictionary can live in the same space, which means that not only, let's say, car and automobile are close to each other because they have similar meaning, but also, let's say, car and automobile in Bulgarian also are close to each other, right? Kind of, you can do that. And then if you start with this, you can start with the word embeddings for the, let's say, Bulgarian sentence, and you can kind of, sum this, and you end up with some representation of the meaning of the, let's say, Bulgarian question, and you have a similar representation of the meaning of the English question because they live in the same space. And now you can just ask the question, are they asking the same question or not? Let's say this is for the question similarity. Okay? And this is kind of a neural network where you have representation of one question, let's say in English, and the other one in English, or this one in Arabic, doesn't matter. It can be different languages, and it goes through the neural network, and maybe some pairwise features, and you make a classification. Some neural network, nothing interesting here, right? But you can also say, you know what? I want to specialize a little bit the neural network so that in the hidden layers, it's impossible to tell whether the original question was in English or was in Bulgarian, or was in English or was in Arabic, okay? And if you can adapt it in such a way, so that this hidden layer here is such that you cannot tell anymore whether the original language was English or Bulgarian, you probably have generalized better, and it's now truly language independent, and it probably is going to work better. So basically you can have a second language classifier that tries taking into account this hidden layer, and maybe, tries to predict whether the original question was in English or was in Arabic, okay? And kind of you try to train those two things together. And this is called adversarial training, because you want a classifier that is very good at telling whether those two questions are asking the same question or not, but is very bad at telling which is the original question. Kind of, if you train the neural network, for the first one, you pass the gradient. For the second one, you invert the gradient. Kind of, you want a classifier that is as bad as possible, okay? So, and you want a very good classifier for the question similarity task, and a very bad classifier for the language task. But, well, kind of, this guy tries to be as good as possible, but you kind of try to fool it. And this is called adversarial training, right? And Jan LeCun, one of the, holy trinity of deep learning these days, right, has said, this is an idea from last year actually, no, probably 2 years old, that generative adversarial neural networks are the most interesting idea in the last 10 years in machine learning, right? And so, I mean, the idea comes really from image analysis, okay? Suppose that I have, I have some kind of generator that generates fake Leonardo da Vinci pictures, okay? And then you have a discriminator, right? A detective that tries to say whether this is original painting or it was kind of fake, okay? So, and then you train those two models together, kind of. You try these guys. I mean, if it was detected, you tell this guy, look, we caught you. And he says, they caught me. Why did they caught me? Okay, let me, update the parameters of my neural network so that they are not going to catch me next time. And, so that you get a better forger, a better, guy doing fake stuff. And the detective kind of tries also to learn, okay, if I could not detect it, why I couldn't detect it? So basically you're kind of, evolving two kinds of, in a way, two neural networks that are somehow connected, right? Where, and in the process, they are jointly trained, you get a very, very good detective and a very, very good forger. And the better one gets, the better the other one gets, right? And kind of, they co-evolve, and you end up with something, and this is the same idea, that was applied before. Okay. And of course, this kind of cross-language community question answering, even with speech interface, we have developed into another demo. I'm going to skip. So a little bit about fact-checking, okay? So fact-checking, I mean, before, I think that kind of factuality is a very important problem. It's not just about, fake news. I mean, let's say question answering. In the years before, it was okay. I mean, we have this. I mean, there's a lot of non-factual information on the web, especially in forums. But they are also kind of. I mean, there's a lot of inaccurate information. So it's not enough to say, okay, I found an answer here to your question, and this sentence really looks like a good answer to your question, so I'm done. No, you're not. You have to also verify that this is actually factual information. Okay, and I'm going to talk a little bit about that. So the first, but kind of a little bit about factuality. So we have done, if you think about it, if you have some article, right? You probably the first thing is if you put your shoes in the fact checkers, journalists doing fact checking, is to find out whether this is worth fact checking in the first place. Okay, and we have done some work in that direction. So, for example, there is this presidential debates that have been analyzed by different fact-checking organizations, so that, let's say PolitiFact, and we are trying to work from this to spot what is worth fact-checking in a particular news. So I was preparing to show you this demo online. I probably can't. Let me just check. 1 second. Okay. So here's some text, right? And I can go here, and I can say, you know what? Let's say, try to predict, and I can mimic, I can work from different fact-checking organizations, like from Chicago Tribune, CNN, FactCheck.org, PolitiFact, and so on and so forth, and you can actually mimic the fact-checking ways of doing it, feature them, and you can imitate, which means that we can, say, okay, if you're a journalist working in PolitiFact, okay, and here's an article or here's an interview, okay, just paste it here, and we are going to predict something that looks like, what you guys are doing in this place. Or you can learn from them all. And if I, for example, say PolitiFact, I say evaluate, okay, it tells me, okay, those are the claims that are probably most worth fact checking. I can also resort. I can also, say, you know what, do this in general, which means kind of learn from all 9 sources that we have, right? And you can learn from all them. And he's like Trump saying, our jobs are fleeing the country, this kind of the most. Okay, let me just sort. Because they are using the country as a piggy bank to rebuild China, and so on and so forth. Kind of you can do this. And this also works in Arabic, right? But I don't want to waste right now time to go and find your Arabic text. I have it prepared in my laptop. But I mean, this is because we use cross-language embeddings, cross-language representation. Even though we have trained this in English, it also works in Arabic. Okay, I'm back to the presentation. Yeah, okay, here here's something in Arabic. And then this is kind of multitask neural network, right? That tries to learn from all tasks, from all kinds of sources simultaneously, because there's some dependency. Okay, so let's go to the next task. I have a claim, right? So for example, Obama wins his 2nd Nobel Peace Prize in 2016, right? And I want to check whether this is true or not. What would a human do? Well, probably you go and you search, right? And then you kind of skim the snippets and you choose some relevant pages, maybe Wikipedia, maybe something else. And then you kind of compare, what is there to what is said. And kind of here you find that it was a word to somebody else and you say, this is fake, right? This is one way that humans would do it. And basically we have automated this process, right? So kind of you take the thing, we kind of, basically, more or less doing these steps. And there's some neural network and so on and so forth. Another kind of relevant task is tense detection, right? So here's a claim, and you want to understand whether a particular article supports this claim or is against it. So for example, there's this claim, Robert Plant ripped up 800 million, let's say, in the reunion contract. And here is something that agrees with this. Here's another article that kind of disagrees. Robert Plant was reported that he, has described as rubbish a Daily Mirror report that he rejected, right? So kind of this article says this is not true. So basically, again, kind of a very simple way to do fact checking is to say, I have this claim, I'm going to query the web or Twitter or whatever. Then I'm going to say how much I trust this web page, this website from which I have found the result. And then take also into account, does it support it or not? And then I'm going to aggregate this information, right? And then we're going to come up with a decision. And we have some very, very complex memory network for that. Now, I mean, there was kind of this fake news, Hack the Fake News initiative. There was a hackathon last year organized by the Data Science Society. Okay, I have some missing thing. Anyway, and you know, some of my students participated there and have won it. And basically, they have, you know, it was on fake news and clickbait detection. And you know, they have some neural network. There's also a paper on that. Now let's go back to question answering in a form. Okay, we have this. I have heard it's not possible to extend visit visa for more than 6 months. Can you please answer me? Thanks. And then you have 3 answers. One says that you can extend it up to 9 months. 2 answers say that you can extend it up to 6 months. Okay, and all 3 are good under our old definition. All 3 are trying to answer the question, as opposed to arguing with other users or something else. And they are direct answers, okay? But they are not factually true. And this is a very, very general problem, right? If you actually go and you find, you know, government websites, you can actually find out that the last 2 are true, the first one is false, okay? So now, what we want to do is, we want to check the answers in a form. I mean, this is kind of the first work that is doing that. And how do you do it? Well, you look at the answer, kind of what is said and how. You look at the author. Can I trust the source, right? Look in the entire form. What is said in other threads, what other users say. Also, kind of, you probably have some trusted users. What do they say, and what is the external support on the web? And you can do other things. And here, I have, again, a demo, right? Let's say, I don't know, let's take this one. Speech, French-speaking nursery. So basically, the question is, does anybody know if there is a French-speaking nursery in Doha? If so, do you have contact details? Thanks. And I don't know, there's this one. There's a French school here, don't know the ages, but name Todd's Corner Nursery, and so on and so forth. And basically here we have some prediction, right? This is a good answer, that is factually true answer. And we have here some explanation how we came up with this. What the external sources say, what the internal sources say, what, you know, the quality, the trusted sources in Qatar Living say, some linguistic analysis, and it's going to be faster if I show you this here. So, for example, here's what the external, kind of, if you just query the web, what you get, I mean, you get that Todd's Corner Nursery is, you know, anyway, you get some idea that those are French schools in Doha. Those are kind of internal sources. I have highlighted things. There are some trusted authors there. I'm not going to go into much detail. And here's like another question. Here the question is, okay, in my view, okay, more salary paying Gulf country. Okay, which is the question is which country pays the most in the Gulf? Okay, and now our classifier has decided this is a wrong answer. The answer is that you know, Kuwait. No. Okay, the question is who is paying the most. My friend says Kuwait, but blah blah. And here the guy says, I think it depends on your job, but I would say the best payers are Saudi Arabia, closely followed by Kuwait. This is not true, okay? And here you see that the language analysis can give you some clues. So for example, the guy says, I think, it depends, I would say, so kind of you see a lot of uncertainty even in the answer itself, so you probably don't trust that answer so much. It's just like to show you some linguistic features. Another thing that is kind of somehow related to factuality and kind of also to forums, right, is about opinion. There's a lot of opinion manipulation going on there, right, in community forums. So, for example, you know, a couple of years ago there were anti-government protests in Bulgaria, and you know, there were kind of, you can go and you can find things like live from the dead protests. There were kind of, you know, people trying to downplay it. I mean, there's kind of a lot of opinion manipulation, of course, and fighting in the forum from both sides. And there were accusations of using paid trolls, and not only that, actually hackers broke into an agency, right, and found reports, that, so basically it turns out that there were like paid trolls, some that were actually asked to hire to write. And he's like, what the kind of the contract is, that if they hire somebody, this guy has to publish 230 comments, typical and involved profile, inform, promote, balance, and counteract. And they were actually given like key points, what to defend in every single day, and so on and so forth. All this is leaked from the web. And basically, there are even kind of spreadsheets like this, okay, because the people that were working for this, they had to, in order to be paid, they had to report. They had to say, okay, today I posted this in this forum under this user, here's the URL, and I posted this text, okay, and everything is there. Right? So, and this is how much, about 10,000 paid posts in different platforms have been posted, and basically we collected this. Okay. So one interesting thing that happened, right? Of course, some of those users deleted their profiles or renamed or whatever, but we have identified some. Another interesting thing that happened is that people, here is translation to English of a Bulgarian thing, but people started accusing each other of being trolls. Okay, it's very interesting. It turns out that users that are accused of being trolls in a way are trolls in the eyes of this kind of forum community. This is an idea that we have explored. So, okay, this kind of Murzilka is kind of a wrong perception in the Bulgarian kind of online communities. They believe this is how trolls are called in Russian. That's not true. I don't know where this misconception comes from. I mean, I was a keynote speaker at a conference in Russia, like 2 years ago, and I was, talking about this a bit, and I was saying Murzilka, and you're like, what are you talking about? And it turns out that nobody calls this like that. So anyway, so basically we have kind of let's say comments by okay, we have different kinds of users that those are accused trolls that other people in the forum call trolls. Those are kind of active users that are never accused of being trolls, and those are kind of 15 really paid trolls. And I mean, I can talk a lot about this, but here we have some kind of comparison between mentioned paid and trolls and kind of non-trolls. Mentioned trolls are kind of that are accused. And in a way, it turns out that if you train a classifier on the kind of accused trolls, you can actually find paid trolls because they are kind of behaving somehow similarly. On the other hand, they are somehow different, right? So, and there are interesting things here. So, for example, let's say, okay, let's say those paid trolls. When do they work? Well, working time, working days. See, right? It's very, very clear, right? And kind of, well, the others, you cannot really tell them apart. Those are accused trolls and normal users, right? I mean, they also kind of, working time, working days, but not exclusively, right? Then let's say non-trolls and mentioned trolls, yeah, okay, they also kind of work in non-working times. No, the paid ones, absolutely not. They don't, right? And also kind of, let's say, the paid trolls somehow attract a lot of negative votes. The others, not so much. I mean, there is interesting analysis here, right? And what is interesting is that, even though this was the Bulgarian space, actually we have studied also Katarlini forum, and users are calling each other trolls there as well, right? And it turns out that if I want to predict whether I should trust one particular answer, a kind of alter in terms of factuality of the answers, not whether he's good or bad answer, but whether those are factually true or not, the trolliness is the most important feature. So if people call somebody a troll many times, this person is very likely to give answers that are not factual. Another thing about answers, right? If you're giving answers to users, you probably want to justify those answers. You want to explain what is the rationale for this. And here I'm going to give you kind of a little bit of motivation from a different viewpoint. Suppose I want to know whether coffee causes cancer, okay? And here the actual answer saying yes or no is not so useful. I mean, what is useful is, okay, his research, that says yes, his research that says no. Maybe you want to write a systematic review, or kind of you want to inform yourself, and things like that, right? So, yeah, okay, so we have some kind of neural network that does that. Another thing is, I have promised to you, I'm almost done, to come back with a chatbot with a little bit different technology. So something that we have done, we have taken the entire Catalytic form and we have turned it into a chatbot. Okay. So basically, what we did is we take the form, we have the question, we first predict which are the good answers. So now we have pairs of questions and answers where the answer is a good answer according to our classifiers. Then we need to find out, because the question can be multiple sentences, the answer can be multiple sentences, we want to find out which part of the question is about which part of the answer, so that you kind of clean it a little bit. Everything is automatic, fully automatic, right? No manual intervention. And then we kind of train some kind of sequence to sequence, whatever neural network that tries to convert, you know, a question to an answer. The sequence to sequence model is basically what the neural machine translation is. It takes the text, converts it into some kind of told vector kind of representation, and then given this one, kind of once we have a representation of the original question, you can generate, an answer. In machine translation, once you have a representation of, let's say, the Bulgarian sentence, from this you can generate, let's say, English or something else. So this is similar to the Microsoft Q&A Maker. Do you guys know the Microsoft Q&A Maker? So it's actually a tool that if you have on your website a FAQ, frequently asked question, you just give it the URL and it builds a chatbot for you. It's very easy, right? You just like you give it, a FAQ, and it builds a kind of chatbot for you. So what we have done is we have done something more complicated. We have a forum, and we are turning the forum into a chatbot, right? I mean, skipping this kind of question answer. And yeah, this is kind of how we find what is the most important part of the question in the answer, with some kind of attention mechanisms and so on and so forth. That, okay, is the best place for snorkeling, and anyway, things like that. And this is how the kind of the machine translation thing works. So if you have a question, how are you, right? Basically, you end up with some representation here, and then given this representation, you start generating an answer. I'm fine. And it's a little bit more complicated. Let me show you some kind of, interactions with this kind of chatbot that I have here. Okay, tell me something about Qatar. It says Qatar is a great place to live. Okay, this is entirely trained only on the forum, nothing else, right? Yes, I know. It says so. Okay. And you say, which is the best bank in Qatar? Doha Bank. I disagree here, but it's okay. What car would you recommend for me to buy? Nissan Kida. Also with the typo. I think Kida is double I. But why? Well, okay. Is 200,000 Qatari riyals a good salary for Qatar? It's good for you to negotiate for a good salary. Okay, that's a good answer. How long can my mother stay in Qatar on a family visa? 0 months. So this is normalization thing, because all numbers are converted to 0. This is an internal issue. Can I extend my family visit visa once she has entered Qatar? You can visit the family visit visa. So I mean, it can kind of, the thing is, okay, not that it doesn't, okay. This model is different from the previous models. In the previous models, we have been looking for a ready answer to show to the users. Here we are generating text that was never set like this in the form, right? Just like in machine translation, you generate given a sentence, a new sentence in the other text. You don't expect exactly this sentence to have ever been set, right? Okay, I'm from Bulgaria. Can I get a Qatari driving license? Yes, you can get a Qatari license. That's very good. And let's see some failures. Where are you from, bot? I'm from India. What is your name? I'm a real name of my name. Okay, you see a little bit of failure. Where do you live? I live in a compound. Okay. Do you like it there? I'm not a fan of my wife. And we have kind of integrated this into Facebook, and I have been looking into putting this into Amazon Echo. Okay, to summarize, I have shown you quite a few things. I mean, mostly started with question answering from a database, and then community question answering, kind of deciding when an answer is good, when it's bad, kind of finding, similar questions, question duplicates, finding good answers to a new question that was never asked before in the forum, and all kinds of, extensions like application to Arabic, cross-language question answering, where you ask in one language, you get the answer in the other one. A little bit about fact-checking, some thoroughness, some answer justification, this I kind of skipped, and a little bit about chatbots. Thank you. Questions? Yes?
Okay, are you answering logical questions with category.com?
So what do you mean by logical? Okay, the question is whether we answer logical questions. So can you kind of explain what you mean by logical question?
Yes, an example. Okay. So you have three gods. One is ever lying, one is ever answering true, and the third one is sometimes true, sometimes false. And can you? And the question to the robot is it possible to find which one is the lying, the truing, and the random god by three questions?
Right. No.
Actually, this is a task.
It is a different task. It is kind of about logical inference, and it's a good point. So there are these days, right? There's kind of a new kind of neural networks that are being defined. Where the answer to a question might need putting together things from different places. So, for example, there is this kind of let's say for conversational. Facebook has this database called Parlay, Barbie. So where the idea is you have a story like this. Peter entered the room. Mary came and brought a book. Peter opened the fridge and took some milk. Peter drank the milk. Peter left the room. Mary took the book, and went, I don't know, and things like that. And then they say, and then somebody, and they ask, where's the book? Right. Or where's the milk? Things like that. So basically, you need to come and you can find several interactions where something happened to this particular object, and you need kind of to find the relationship between them in order to understand what actually happened. So the idea there is that you don't do here, for example, you want to find out, here's the question, you just need one answer, but in this particular data set, you cannot answer with just one thing. In order to understand what happened, you need to do this kind of logical inference. It's a little bit simpler than what you are describing, but it means that I need to take into account this piece of information, and this piece, and then it's kind of multiple term thing, and this kind of memory network. It's a very interesting research. Yes?
How do you deal with the expiration of the facts? So generally with driving license was good, okay, 6 months to explore or something like that. And today it's changed from 6 months to 9 months.
Yes.
How the correctness, because the answer will be still valid. I mean, it's 6 months, but it's already obsolete as a correct answer.
Right.
The correct answer right now became 9 months.
Right.
So how do you do?
Right. So the question is, how do we deal with kind of temporality, right? So things can change over time, right? So I mean, it's actually even annotating the data, right? When we have been doing, okay, here's a question, here's an answer. You want to have some training data or at least testing to know whether our algorithm is doing the right thing. You wanted to have factual annotation, right? And there were things like, is there an IKEA in Qatar? Okay. Of course, at some point there was not. At some point there was, right? So I mean, kind of the temporality is very, very important. So our solution was to have, there's another thing. Is tomorrow a working day? Or things like that. So basically we have like extremely time-sensitive questions, and those we just, they are a completely different category. For others, our stance on factuality was what is the present tense of affairs. So not when the answer was given, but as of today, if I'm doing fact-checking today, is it true today? This was our stance. So kind of when we are fact-checking, for example, whether it's 9 months or 6 months, we don't care whether this guy was correct or not back 2 years ago when he gave the answer. We care whether it's true as of today or not. So kind of when we are doing fact-checking, we are taking the present as a reference point. But I mean, kind of temporality is a big issue. I mean, things change over time. Some change very fast.
Because you have to train constantly.
I mean, we don't really train. So basically, kind of the way that we do the fact-checking, right? We go and we, let's say, check on the web. but you are right. I mean, you also need to see how fresh is this information there in the first place. Yeah, temporality is an issue. Yeah. Yes.
You mentioned at the beginning of the talk, and then later you mentioned it again while talking about the chatbots. And from what you've shown, Lebanese and Doha is the only thing that's important. Of course, for the question that was at hand, this was important information. But how does the algorithm decide which is important and not important? Obviously, a technical question.
Right. So, okay. So the question is, if I say, is there a Lebanese cafe in Doha? Lebanese is about cuisine. If I say, is there a Lebanese woman in Doha? It's not about cuisine. So you should get the different label.
Yeah.
So basically, okay, when we train this kind of model, right, we have trained it on 50,000 interactions that are manually annotated. So and this kind of condition, this model, right, it looks not only at the content of the particular word, but also kind of at the surrounding. So it's and then kind of it doesn't look at the word itself as well only, like woman. It's going to also kind of look at the word embeddings, which means that any word that is kind of looking a little bit like you know, this class of objects, right, is probably going to influence the decision in this particular way. So and you know, we.
And the same goes for the chatbots as well, probably.
Yeah.
Okay, thank you.
Yes.
Yeah. When I saw for the trolls identification, because what I saw, you make a feature extraction, and then I guess it was supervised. But did you try unsupervised and did you saw more groups rather than these three?
So the question is whether kind of for the trolls, whether we tried anything unsupervised or we only did supervised training. So we only did supervised training, but there are other interesting aspects, right? So for example, somebody might come and rename themselves, or somebody is kind of also sock puppeting, right? Sock puppeting is where somebody calls himself, you know, and they're like, it's somehow kind of different users. I mean, this is also something very interesting, right, to detect that it's actually the same user. It can even start arguing with himself or kind of supporting, you know, each other's arguments, and those things probably happen. Or let's say there is this, after those trolls were exposed, right? Some of them probably just like continued doing the same thing under new profiles, right? So kind of, I think that some work on authorship attribution, trying to find out, look, this guy and this guy are the same person. That would be interesting, right, to connect, and that's not. Of course, the problem is how do you get training data for that, right? So it all goes to the data, right? I mean, okay, we can do some kind of clustering, you know, might be interesting, you know, to show to people, but I mean, let's say there has been a lot of research on trolliness, right? But typically, I mean, this is the only data that I'm aware of where we have gold annotations. So there was work on, let's say, in China on Internet Water Army, right? Where kind of, okay, so let's say the ruling party is, you know, hiring trolls to do whatever, right? And there have been like annotated several thousands of users, but how it was annotated? Well, perception. Okay, do you think that this looks like a troll comment or like a troll user? Okay, maybe it looks to you, maybe it looks to me, maybe everybody looks like a paid troll, but maybe it's not a paid troll, right? Now we have gold data. It's something unique. I mean, I have not seen this, you know, from any other language, right? Unfortunately, it's very little. We have only 15 users, right? Because, I mean, because we have been only looking in the forum of Dnevnik and Capital, right? I mean, there is more on Facebook, there's more in other media, but other questions? No. Good. Thank you.
Those a bit behind on time, can I just ask just to do a 10-minute break, and then we'll proceed with the keynote speech of Professor Maragali. So we start really at 4:45.